Right. So let's put it in this way: the current usage of this material. So I will give one example, maybe two if I get little time. So one example that I would like to give is called direct air capture. I repeat, direct air capture. So what is direct air capture? So I mean, from the name itself, direct air capture. So that means you are capturing air. So how you will capture air? So we are, surrounded by air. So, which means that in your surrounding, whatever is your environment or whatever, wherever you are sitting, let's say at your home or in the playground or somewhere, you absorb that CO2 which is present in your surrounding. Let's say inside the room from where you are doing this video. So there I would like to say that inside that room there should not be any CO2. Period. Okay, let's put it in this way. So now, let's say whatever the size of the room, there are, let's say, 1 lakh or 10 lakhs air particles are there. 10 lakhs. Out of which, as we know, that 70% is nitrogen, 69% something is nitrogen. Close to 30% is oxygen, so 99% is gone in oxygen and nitrogen only. And less than 1% is rest of the things. That's why that is the reason we can still survive. If it is more than that, we will not be able to survive. So out of which, if there are 10 lakh air particles are there, so only 400 particles will be CO2. 400. Rest are either nitrogen or oxygen. Okay. So now you have to invent a material which will selectively absorb only those 400 particles. Nothing else. It cannot absorb oxygen. It cannot absorb nitrogen. It will only absorb those 400 which are scattered in your room. Something may be in your ceiling, something may be next to you, something may be somewhere else, but it will absorb one by one, slowly, with time, the entirety of the carbon dioxide. So now you can imagine what is the game here.
Yes, sir.
These materials can do that job selectively. So this is the important part of it. Now, there is a question. So is it the only material that can do this job? No, it's not true. Zeolites can do that job also. Actually, zeolites can do that job much better. Then why this material picked up the most? Because zeolites, if you keep it in your room or wherever you are there, though it can absorb the CO2 much better, those carbon dioxide particles better, but it can absorb moisture even better. Even better. So let's put it in this way. You are eating rice and dal or something, sabji and chapati, those kind of things every day. Then one fine day, I will tell you, let's go to a restaurant and we will eat. So when you go to the restaurant, will you eat the same sabji and chapati and all these things? Of course not. You are definitely going to eat something else. So this is called selectivity. So it is called, so you are selective now. Though you have option to eat the same thing, but you are not eating. So when you get an opportunity, so that means when zeolite is only trapped or surrounded by carbon dioxide, it will only absorb carbon dioxide. But if you give it an option to choose between carbon dioxide and water, it will choose water. Like we go to a restaurant, we will order some, let's say, mutton, chicken, fish, whatever. This, that, whatever, those kind of things we will order. Or we will order some nice veg thali or something like that. Okay, but we are not going to eat the same thing what we are eating in.
Sir. So they are more selective.
Selective towards water.
Towards water, yeah.
Whereas these materials are more selective towards carbon dioxide. So even in presence of water, they will they will do the job.
Understood, sir. That's a really nice explanation, sir.
So
And
this is the one of the reasons. So there are other things. There is called desert water uptake. So when inside the desert, the only important thing is water. Nothing else matters. So clean water, and it is not only the desert. If you go to our rural villages, let's say Sundarban area or Midnapur or Purulia, and those kind of places, you will see that people have lots and lots of difficulty of getting, let's say, one bottle of drinking water. It's a miserable situation.
true, true, sir.
And we over here in Kolkata and on suburban places and all, we buy a bottle and we drink, and half of it is still there, we throw it,
Yeah.
So we don't really care. But this is a very important thing that this material can do. This can actually absorb moisture. So you see, this is a contradictory statement. I just now told that these materials should not absorb moisture. It will only absorb CO2. But again, I am saying these materials can absorb moisture from the environment and condense it within itself at a particular temperature. And at a higher temperature, it will release that moisture. So if you keep it in a closed environment, so at night time, it will absorb moisture. And in the daytime, when the temperature is higher, so it will desorb the moisture into another container.
So temperature is also a game here.
Also a factor. But this temperature, anyway, it is happening. Nighttime, our temperature is low. Daytime, our temperature is, so nighttime it is about 25 degrees, daytime it is about 35 degrees, something like that, right? So at nighttime, at 25, it will absorb.
Okay.
At 35, it will desorb. So you can understand, this is also a very interesting thing. But these two materials are different. And that is the beauty of this metal organic framework field. So based on your choice of the property or the applications that you need, you can design the material. That is the beauty.